Hello everyone. Today we'll be looking at how to determine if two functions are inverses of each other. So before we actually look at how we do that, we're going to first make sure we know how to find composite functions. So let's use this review problem to see if we can find the composite functions f of g of x and g of f of x, given that f of x equals 2x squared minus 5x and that g of x equals x plus 1. So let's first find our composite function f of g of x. To do this, we're just going to plug the entire function of g of x into anywhere in f where there is an x. Doing this, we get 2 times x plus 1 squared minus 5 times x plus 1. If we expand out this x plus 1 squared and do our FOIL method, we have our composite function being equal to 2 times x squared plus 2x plus 1 minus 5x minus 5. When we distribute that 2 and combine like terms, we are left with our composite function being equal to 2x squared minus x minus 3. We could factor this if we wanted to, but this is a perfectly fine form to leave it in for the composite function. Now, let's find g of f of x. We're going to use the same process by plugging in the entire function of f of x into anywhere in g where there is an x variable. Doing this, we get 2x squared minus 5x plus 1. We can simply remove those parentheses, leaving us with a composite function of 2x squared minus 5x plus 1. So, now that we know how to find composite functions, let's use this knowledge to determine if two functions are inverses of each other. To do this, we can determine if two functions are inverses of each other if the composite function f of g of x is equal to x and the composite function g of f of x is equal to x. So both of the composite functions need to be equal to x. And this is because we know inverse operations undo each other, meaning that the inverse operations of one function undo the operations of the other. So, using this technique, can we conclude that the composite functions we calculated above, f of g of x and g of f of x, imply that our two functions are inverses of each other? And since f of g of x and g of f of x are both not equal to x, we know that no, our two functions f of x and g of x above are not inverses. Now let's do some more examples. We are given, in example 1, that f of x is equal to 2x plus 7, and that g of x is equal to x minus 7 over 2. So, let's first find f of g of x. Remember, we're plugging in the entire function of g of x into anywhere in f where there is an x variable. Doing this, we get 2 times x minus 7 over 2 plus 7. As you can see, these cancel out, leaving us with x minus 7 plus 7. These two 7s cancel out, leaving us with just x. Since the composite function f of g of x equals x, we automatically need to go ahead and solve for g of f of x to truly determine if these two functions are inverses of each other. So, solving for g of f of x, we're plugging in f of x into anywhere in g where there's an x variable. We get 2x plus 7 minus 7 all over 2. As you can see, these 7s cancel out, leaving us with 2x over 2, which simplifies to x. Since we know that both of our composite functions are equal to x, we can conclude that yes, these two functions, f of x and g of x, are inverses of each other. Let's do another example. We are given that f of x is equal to negative 10x plus 5, and that g of x is equal to x minus 5 over 10. So, doing the same steps, let's first find f of g of x. So, plugging in g of x into anywhere in f where there is an x variable, we get negative 10 times x minus 5 over 10 plus 5. And we can see that these two 10s cancel out, leaving us with negative outside of the parentheses times x minus 5 plus 5. We distribute that negative sign, leaving us with negative x plus 5 plus 5. And we see that this simplifies to negative x plus 10. Since our composite function f of g of x did not simplify to just x, we can go ahead and stop our work here and conclude that no, these two functions are not inverses of each other because the inverse operations of g of x did not completely cancel out the operations of f of x. So we don't even need to go and solve for g of f of x in this case because the first composite function was not equal to x. So now it's your turn to try. If we are given that f of x is equal to negative 5x plus 1 and that g of x is equal to negative x plus 1 over 5, can you determine if these two functions are inverses? Pause the video and try it for yourself. Hopefully you gave yourself some time to solve this problem. Now let's work through it together and see what we get. So, first solving for f of g of x, we're plugging in the function g of x into anywhere in f where there's an x variable. We get negative 5 times negative x plus 1 over 5 plus 1. We see that these two 5s cancel out, leaving us with the negative outside of the parentheses, negative x plus 1 plus 1. We distribute this negative, leaving us with x minus 1 plus 1. These two 1s cancel out, leaving us with just x. So since our first composite function, f of g of x is equal to x, we know we automatically need to solve for g of f of x. So let's go ahead and do that. Plugging in f of x into anywhere in g where there is an x variable, we get negative, outside of the parentheses, times negative 5x plus 1 over 5. So let's go ahead and distribute this negative, leaving us with 5x minus 1. We see that these two 1s cancel out right here, leaving us with 5x over 5, which simplifies to x. Since both of these composite functions are equal to x, we can conclude that yes, these two functions, f of x and g of x, are inverses of each other. Now, let's dive a little bit deeper into this concept and see if we can determine if exponential and logarithmic functions are inverses of each other. So before we do this, let's make sure we can determine the inverses of exponential and logarithmic functions. So in the first review question, in review A, we need to find the inverse of f of x. So to do this, we switch the places of x and y. So we're going to say x is equal to 8 times 10 to the y. And then we have to isolate y all over again to get the inverse. So let's first divide out this 8, leaving us with x over 8 equals 10 to the y. And in order to isolate that y in the exponent, we're going to have to use a logarithmic function. So to do this, we're going to say that log base 10 of x over 8 is equal to y. And that is our inverse. So log base 10, and you don't technically have to write that base 10, but you can if you want. Log base 10 of x over 8 is equal to y, not times y, equal to y. There we go. Now, let's do this again for the second review question, review B. So we have f of x being equal to log base 4 of x plus 15. We're going to switch the places of x and y. So we're going to have x equals log base 4 of y plus 15. Let's first subtract out that 15 from both sides, leaving us with x minus 15 equals log base 4 of y. Let's put parentheses around that x minus 15 so we know that we need to keep that together. And so to isolate this y from this logarithm, we're going to have to use an exponent. So we're going to say that 4 to the power of x minus 15 is equal to y. And that's going to be our inverse. So 4 to the power of x minus 15 is equal to y. So now that we know how to find the inverses of exponential and logarithmic functions, let's use this knowledge and what we've previously talked about to determine if two exponential and logarithmic functions are inverses of each other. So let's look at this third example. We are given that f of x is equal to 3 to the x minus 1, and that g of x is equal to log base 3 of x plus 1. Same steps as before. Let's first find our composite function f of g of x. So we're plugging in the entire function of g of x anywhere into f where there is an x variable. Doing this, we get 3 to the power of log base 3 of x plus 1 minus 1. And that minus 1 is not in the exponent. So since we see that the base of this log and the base of this exponent are the same, we cancel out, leaving us with x plus 1 minus 1. We see that these 1's cancel out, leaving us with just x. So, since our first composite function is equal to x, we know that we automatically have to solve for the second composite function and make sure that it's equal to x. So, finding g of f of x, we plug in the entire function f of x into anywhere in g where there's an x variable. Doing this, we get log base 3 of 3 to the x minus 1 plus 1. So we see that these two 1's cancel out, leaving us with log base 3 of 3x. And since the base of this log and the base of this exponent are the same, they essentially cancel out, leaving us with just x. So, like we said before, since both of our composite functions are equal to x, we can conclude that yes, these two functions, f of x and g of x, are inverses of each other. Now this is your turn to try it. Given that f of x is equal to natural log of 2x minus 3, and that g of x is equal to 1/2 e to the x minus 3, see if you can determine if these two functions are inverses by finding the composite functions. Pause this video and try it for yourself. Hopefully you gave yourself some time to solve this example. Now let's work through it together and see what we get. So first, finding the composite function f of g of x, we're plugging in the entire function of g of x into anywhere in f where there is an x variable. So doing this, we get the natural log of 2 times 1/2 e to the x minus 3, that entire thing, plus 3. And make sure you get those parentheses right, because that minus 3 is outside of that natural log. I almost made that mistake. So make sure that you're looking at where those parentheses end. So that minus 3 is outside of that natural log. So distributing this 2, you get the natural log of e to the x minus 6, parentheses, minus 3. That minus 3 is still outside of the natural log function. So we can stop right here, and we can go ahead and see that this function will not simplify to x, as we can already see that this negative 6 and negative 3 will not cancel out. So we can go ahead and stop our work here and conclude that no, these two functions are not inverses of each other. Therefore, we don't even have to solve for g of f of x. Okay, so let's do this again in the fourth example. We are given that f of x is equal to 2 log base 4 of x plus 3, and that g of x is equal to 2 to the x minus 3 power. Now, same steps as before. Let's first find the composite function f of g of x. Plugging g of x into anywhere in f where there is an x variable, we get 2 times log base 4 of 2 to the x minus 3 power plus 3. So we can go ahead and stop right here because we can't really simplify it further, and we can already see that this plus 3 will not cancel out, meaning that we're not going to be able to simplify this composite function to just x. So we know that these two functions, f of x and g of x, are not inverses of each other. And we don't even have to solve for g of f of x because that first composite function was not equal to x. Okay, last example, I promise. Given that f of x is equal to negative log of x minus 4, and that g of x is equal to 10 to the power of negative x minus 4, I want you to see if you can determine if these two functions are inverses of each other. So pause this video and try it for yourself. Hopefully you gave yourself some time to solve this problem. Again, let's work through this together and see what we get. So first, solving for the composite function f of g of x, plugging in g of x in anywhere in f where there's an x variable, we get negative log base 10, remember that base 10 is implied, times 10, or negative log base 10 of 10 to the negative x minus 4 power, parentheses, minus 4. we can simplify from here, knowing that this is log base 10. Since the base of this log and the base of this exponent are the same, they cancel out. Leaving us with negative. Don't forget that negative sign. Negative x minus 4 minus 4. Distribute the negative sign, leaving us with x plus 4 minus 4. These cancel out, leaving us with just x. So we know we automatically need to solve for the next composite function, g of f of x. So let's come over here and do that. Plugging in f of x into anywhere in g where there's an x variable, we get 10 to the power of negative quantity, negative log base 10 of x. Don't forget that base 10, minus 4, and then minus 4. So let's go ahead and distribute this negative. We get log base 10 of x plus 4. We see that these two 4's cancel out. And so we're left with 10 to the log base 10 of x. Remember that base 10 is implied. Since the base of the exponent and the base of the log are the same, they essentially cancel out, leaving us with just x. So, like we've established before, since both of these composite functions are equal to just x, we can conclude that yes, these two functions, f of x and g of x, are indeed inverses of each other. Okay, I hope this video helped you better understand how to determine if two functions are inverses of each other, and it refreshed your knowledge on how to find the inverses of exponential and logarithmic functions, and I hope you have a terrific rest of your day. Thank you for watching.